So this first unit in pre-calculus, we're going to spend a lot of time talking about graphs, okay, analyzing graphs, looking at different graphical characteristics. How can we relate graphs to the function notation that we kind of reviewed last week? So it's going to be a lot of graphing. Some of you might like it, some of you might not, but we're going to go over it anyway just so we can get used to visually understanding what a picture or a graph means. So in this first section, we're going to talk about shifting, reflecting, and stretching graphs. And I think this is kind of interesting because we're going to, I'm hoping we get so good at just looking at an equation that we can automatically picture what the graph looks like in our head, okay, just by the way the equation looks. So we're going to get really good with graphing these by hand, okay, not necessarily relying on our calculator to do that for us. Now we will use a calculator today just to get used to what some of these graphs are going to look like, so make sure you have one handy, but eventually we're not going to be using one of these, okay? So what we're going to do is take a look at some basic types of graphs. I know you're already familiar with lines. I know you're already familiar with parabolas, okay, those U-shapes, but there are some other basic shaped graphs like square roots, cube roots, rational functions. So there's some other ones as well. Okay, so we're going to get used to just identifying a graph based off of its shape. What I want to do in part A is just graph the basic beginning square root function. So I know we can do this without a calculator. Good morning. Anything for the office today? I think we're good. Thank you. Have a good day. All right. So without, yeah, there's an electric one in the back. How might you want to graph the square root function? Or maybe some of us are already familiar with what that might look like. How can you graph an equation by hand? We have no idea. Don't overthink it. Do I need my sticks? Let's see. Cool. You have an idea? How can we graph a function by hand? You don't know? Yeah, Alex?
Just create a table.
Pick some points. Create a table. Yeah. That's an x, right? That's a variable, right? You can let that be any number you want, right? Pick a number. What's an easy number we can take the square root of? Yeah? 4. All right, if you plug in 4, the square root of 4 is 2. There's a point, all right? At least that's starting us with something. But the more points we have, the more accurate our graph is going to be. So what's another easy number that we can take the square root of? Yeah? 1. Square root of 1 is 1. Square root of 9, 3. Now I know that's not exactly on your graph, but we can kind of imagine where it might be. What about the square root of 0? Yeah, that is 0. What about the square root of negative 1? I'm seeing head nods. Yeah? You cannot take the square root of a negative number. It happens to be imaginary, that little I. Maybe you've seen that before, okay? So this 0, 0 origin point is kind of like the starting point, and notice how it's going to kind of curve upwards from there. So if you can imagine a half of a parabola on its side, that's basically a square root function. So since this is the basic one, notice how this is just the square root of x. There's no plus 2, minus 2, anything else going on. We're going to refer to this as the parent function. Parent meaning the one that you start with. And then all the other ones that we're going to take a look at today are basically the children ones, okay, the offspring. What if you change it? Okay, how is that going to change the way this graph looks? So the beginning function is sometimes referred to as the parent function. So let's think about b. What if we were to take the basic square root of x equation, okay, basically this graph, and we were to add 2 on the end of it? How do you think that would change this graph? Yeah.
It would go up on the y-axis by 2.
Okay, so let's test it out. Let's go ahead and use those same ordered pairs from before. If we plugged in 0, we got 0, but then we have to add 2 to that value. So this time when we plug in 0, we actually get out 2. If we plug in 1, the square root of 1 is 1, but then we have to add 2 to that, so we get 3. And then if we plug in 4, square root of 4 is 2. Add 2, we get 4. And then if we plug in 9, square root of 9 is 3, plus 2, we get 5. So here is a transformed graph. Notice how it's the same shape as the parent one. It's just shifted a little bit. And more specifically, it was shifted up 2 units. So this plus 2 on the end is causing your graph to move up that many spots. Now, can we use some educated guesses here and think about what C is going to do? Yeah. It's going to go down. Hey, there you go. So we're going to take the original parent graph, and this time if we were to subtract 2 from the values, that graph would move down 2 spots. So we're basically taking all of those beginning points and moving them down 2 units. We doing okay? We're transforming graphs. All right. What about D? We're going to switch it up a bit. This time we're adding 2, but it happens to be on the inside of the square root, not tacked on the end like it was previously. So can we take an educated guess about how this plus 2 on the inside would change the beginning graph? Yeah?
It would be x plus 2 to equal a perfect square.
Okay. So how do you think we'd be moving it? So this one moved up 2, this one moved down 2. What do you think this one is going to do? Left, maybe? Okay, let's check it out. So this time, if we try to plug in 0, we're going to get 0 plus 2, but we don't know the square root of 2. Okay, so we got to think about an easy number we can add, or we can substitute in there. That way we add 2, we get a perfect square like Pietro said. Yeah. 2. All right, so if we plug in 2, 2 plus 2 is 4, square root of 4 is 2. So if we plug in 2, we get out 2. So there's a point. Can we think of some other numbers we can substitute in that would give us perfect squares? Another one? Yeah. Negative 1. Okay, so we know we cannot take the square root of a negative, but notice how we can substitute in a negative. If we substitute in negative 1 and then add 2, that's going to change it to a positive 1, which we definitely can take the square root of. So if we plug in negative 1, the square root of 1 would end up being 1. Okay? There's some other ones. Go, Cole. Negative 2 plus 2 is 0. Square root of 0 is 0. Good. Hi. Okay. Is there another one? Yeah? 7. Okay, 7 plus 2 is 9. Square root of 9 is 3. So plug in 7, get out 3. I'd say that's pretty good. So if we take a look at this graph compared to the parent one, the beginning one at the top, it actually moved left 2 spots, because notice how that beginning point was at the origin and now it's at negative 2. So this is what's a little tricky. Okay, at first glance you see that plus 2 on the inside, and I'm pretty sure your brain is thinking, oh, it might go right because positive is kind of a right direction, but it's actually going left. So the inside's the tricky part. It kind of does the opposite of what you would think. Okay, but notice how the outside values actually move kind of in a common sense direction. If you add on the outside, it goes up. If you subtract on the outside, it goes down. All right, so educated guess for E. How do you think that's going to shift or move our parent graph? Good, Adam? To the right 2. Okay, so all those points on the parent function, which you can't see, there we go. All those points on the parent function, if we were to shift them right 2, that's what this graph would look like. So let's move each point right 2 spots. Again, the inside kind of does the opposite of what you would think. So notice how if we're subtracting 2, it's actually moving right. All right, so depending where we're adding or subtracting, that's shifting our graph either up or down or left or right. What if we were to throw in a negative? What do you think, Jordan? It's going to say it again? Oh, okay, so it's going to flip over the x-axis. So notice how all of these points, if we were to make them negative, they would now be below the x-axis. Now, if we made this beginning point negative, making 0 negative doesn't really affect anything, but the next point has a height of 1. So if we make that negative, it'll now be -1. The next point has a height of 2, so make that negative, it'd be -2. And then the last point had a height of 3, so make that negative, it'd be -3. So if you have a negative on the outside, you're flipping your graph upside down. This is called a reflection. Kind of like if you're looking in the mirror, a mirror image, okay, but it's a reflection over the x-axis. All right, so right now this is kind of basic where we're just doing one thing to the equation, we're just moving it one way or we're just flipping it, but we can get involved with some of these. Maybe we want to do more than one change or transformation. So we're going to kind of check those out on the back. Okay, so if you take a look at G, notice how we have 2 things going on in this function. We are multiplying by 2 on the outside, and now we have a negative on the inside. Okay, which is a little different than the previous one. So what I want to do is, since this one's a little bit more involved, I want to go ahead and graph it on the calculator just to get a good picture of it, and then we'll analyze the picture to determine what those 2 things actually did to that parent graph. Okay, how did it change it? So let's go into y equals, if you have anything in there you can clear it out, and we'll type in 2 square root, and then we'll type in -x. Before we hit graph, let's go to window, and we'll make our window the same as what's on our paper. So notice how the x's go from -8 to +8, counting by ones, and then same for the y's. All right, so there's our picture. Let's go ahead and find some exact ordered pairs on this so we can plot the points appropriately. So if you want to get ordered pairs, we can hit the trace button, which is going to bring up that spider, and you can type in any x value you want. So notice how if you hit trace, it starts at 0, 0, so we'll go ahead and plot that point. But you can just simply type in any number you want. For instance, if I type the number 1, notice how it'll automatically select that as an x value. And if you hit enter, it will give you the y value. Now, notice how the y value for this one is blank. Why do you think that is? Yeah?
Because whenever you put it into the equation, you multiply it by the -1, which would make it -1, and you can't get the square root of the negative number.
There you go. So I tried to substitute in 1, but notice how the negative in the equation would make that a -1, and you can't take the square root. So I tried to plug in 1, but I didn't get anything out. It looks like most of the graph is on the negative side. So what if I just type in -1? notice how I do get out a y value. So on your graph, on your paper, if you plug in -1, you get out 2. Go ahead and plot some other points. Type in some other values. If you try -2, notice how you get a decimal. Maybe that one isn't a good one to pick. Doesn't look like -3 is either. -4 works. All right. If you try to type in -9, okay, and you hit enter, notice how you'll get an invalid message. Why do you think that is? Yeah. The window's too small. Okay, we only made our window go out to -8. So you're trying to type in a value that your calculator can't see. Okay, so that's why it's invalid. So if you want to type in other values, you might have to change your window. I'd say that's pretty good. We'll just go ahead and connect those to get our rough shape. Okay, so something like that. So now that we have a picture of it, can we think about what the 2 did to the parent function and what the negative on the inside did to the parent function? If you can't remember the parent function shape, okay, you can flip it to the other side. It's the very first one we did. What do you notice? What do you think, Ashley? Made it wider. Okay, so this 2 made it wider or stretched it somehow. Okay, so this is what's called a vertical stretch. We'll talk about that in a second. So vertical stretch specifically by 2. What about the negative on the inside? Yeah? Reflected it. Okay, so if we look back previously, okay, you don't have to flip your page because I have it up here. If we had a negative on the inside, notice how it flipped the parent graph upside down, okay, and we had this shape. But this one was flipped also, but it wasn't upside down. How was this one flipped? Yeah.
Over the y-axis.
Over the y-axis. It was flipped left and right. Okay, so a negative on the outside flips it upside down, whereas a negative on the inside flips it left and right. Okay, it's a different axis. So vertical stretch by 2, and we'll say flip or reflection, whatever word you want to use, flip over y-axis. Okay, so the negative on the inside is flipping it left and right. I do want to pay attention to the vertical stretch though, this is kind of the more difficult one to analyze out of all these transformations. If you were to take a look at the parent function and you were to find what I call the initial slope. So if you take a look at the beginning point and the very next point you have and you calculate rise over run, notice how on the parent graph that's 1. Okay, because there's like an invisible coefficient of 1 there. Okay, understood 1. If you take a look on the one that we just did, okay, from beginning point to next point, notice how that's now a slope of 2. Okay, you have to go up 2 units to get to the next one. So that's this vertical stretch. Okay, the initial slope is changing. So you're actually multiplying all the y values by 2. Okay, you're stretching it almost like an accordion, or you're making it wider. Okay? Let's try the next one. A little bit more involved. Let's go ahead and graph it just to get a good picture. So we'll have the square root of -x minus 2. Now, before you hit graph, some of you may have already done that. Before you hit graph, can we anticipate what these transformations are going to do? Can we think about what the graph should look like? What do you think, Jordan? How'd you know to the left?
Because it has a negative on the inside.
Okay, so left 2, perhaps. What else is going on in there? Yeah? Negative x is a reflection over the y. So we're going to flip it left and right and possibly move it left 2. Now let me ask you this. This -2 on the inside, was very similar to this minus 2 on the inside, which we said moved right. So at first glance, maybe this should actually move right 2 and then flipped over the y-axis. Okay, just by looking at it. Let's see if our guess is confirmed by our calculator. All right, it's definitely flipped over the y-axis because instead of going this way, it's now going this way. But did it move right too? No. Notice how that beginning point is actually to the left now. All right, so let's go ahead and plot some of those points. Hit the trace button and just type in some values. If we plug in -2, we get 0. Try to find another good one. -6 would give us 2. All right, I'd say that's a pretty good shape. All right, so based off the graph on our calculator, this one actually moved right 2 and a y-axis reflection or flip. Okay. Why do you think this one moved, or sorry, this one moved left 2? We thought it was going to move right. Okay. This one actually moved left 2. Why do you think that this -2 moves left, whereas the previous -2 moved right? Autumn, you have an idea? The x is negative. Okay, so remember, the inside kind of does the opposite of what you would think. If that negative in front of the x wasn't there, it would definitely move right too. But the fact that the negative is in there, that's changing it. You're making it the opposite because that negative is placed in front of the x. So it's a little tricky. Whenever there's a negative in front of the x, the way it moves left and right is actually changed. Okay, so a little side note, we got to be careful. We'll say careful with inside negatives. Okay. It's actually changing the way your graph moves. So let's try the next one. Okay, just looking at it, can we look at the equation and think about how the original parent graph is being moved? You gotta ask yourself, are we adding, subtracting on the outside, inside? Do we have any negatives? What do you think? Go ahead, Alex.
It's going to flip over the y-axis, and it's going to go right.
Y-axis flip. Okay, that's the negative on the x. And a +2 on the inside would normally go left. Okay, the opposite of what you would think. But since we had that negative on the inside, it changes it. So this one's actually going to go right too. Okay, so let's go ahead and for now we'll graph it on our calculator just to get a visual. We're eventually going to do these by hand, and that's coming up real soon. All right, so it looks like the calculator confirmed our guess. Okay, it was flipped over the y and it moved right too. So you can hit the trace button and then type in any value you want to find some ordered pairs. We doing okay so far? All right, let's go ahead and try some of the ones at the bottom. So we're still dealing with that square root function, okay, the basic graph that we had previously, but now we're going to really amp it up. So notice how the equations we have now have many transformations. So we have to be careful on how we apply these because there is a specific order where you have to go through and list all your transformations. So for that order, we're going to write it down at the bottom. Have any of us seen Wheel of Fortune? Yeah? Do you remember the letters at the end when they do the big, like, aha? Yeah? There you go. All right, so RST is what I want you to remember. Actually, alphabetical order, right? RST. So what do you think the R stands for in terms of these transformations? Have we used an R today? Yeah. Reflect. Okay, so whenever we're going to graph these by hand, we have to apply the reflections first. The S stands for that stretch. Okay, if we have that vertical stretch, making it wider or taller. And then the T stands for translation. That's when you move it like up, down, left, or right. Okay, those are done last. So I want you to think about RST. Okay, alphabetical order, Wheel of Fortune, whatever helps you remember that. Okay, so we're going to do this without a calculator, and then we'll check it with a calculator just to make sure that we did everything right. Can we take a look at this equation and we'll identify any of these changes? Can you identify a reflection somewhere? Where is it and how are we reflecting? Yeah. How'd you know? Negative on the inside. Okay, so this is a y-axis flip. All right. Are there any other reflections? Those are just your negatives. No. All right. Do we have a stretch? What do you think, Mike?
Yeah.
Where is it?
Because like the two on the outside.
All right. So this is our vertical stretch by 2. Okay, so we're going to double all the heights. We're actually going to make it very tall. Do we have any translations, like left, right, up, down movements? What do you think, Jordan?
We're gonna go for the right one, and then down 3.
There we go. Right 1, down 3. Okay, now, if the minus or the negative was not there, the +1 would actually make it move left. The inside does the opposite of what you'd think, unless there's a negative on the inside, which changes it. Okay, so we can identify all these transformations. Now we're actually going to apply it. So what I want you to do, most of us are using pencil, which is okay. I want to go ahead and start by graphing the parent function, okay, the beginning one that we have. So if you were to think about the basic square root graph, I want to go ahead and plot those points, which we already did previously. We plugged in 0, got 0, plugged in 1, got 1, plugged in 4, got 2, plugged in 9, got 3. Okay. I want you to label this graph P for parent function. So now what we're going to do is take all of those beginning parent points and we have to first reflect them over the y-axis. So we're going to move all the points, flipping them left or from right to left. So this beginning point here at the origin, if you were to flip that over the y-axis, it's already on the y-axis, so it's really not going to move anywhere. But this next point, notice how it's 1 unit away from the y-axis. So if you flip it over, it's going to be 1 unit away on the other side. So I want you to imagine taking that black graph, folding it over the y-axis, and the y-axis is where you would make the crease, okay, of that fold. So if we do the other points, this point, if we fold it over, would land here. And this point, if we fold it over, would land over here. Okay. I want you to label that graph R for reflection. All right. Our next transformation we're going to go through is the stretch. So all of these blue points, okay, we're no longer using the black ones because we changed the black points to the blue ones. All of these blue points, we need to vertically stretch by 2. Okay, we're going to double their heights. So taking a look at that beginning point, which has a height of 0, if you double 0, that's not going to move, so it's still going to be there. But the next point has a height of 1. If you double that, that point is now at 2. The next point has a height of 2. If you double that, it's now at 4. And our last point had a height of 3. If you double that, you get up to 6. So we're taking the blue graph and we're kind of pulling it or stretching it upwards, which is now making my red graph. I want you to label that one S because we stretched it. All right, so we're going in order. We started with the parent, and then we reflected it, and we stretched it. Last, we need translations. So all of the red points, we're going to move right 1 unit, and then down 3 units. Now it might get confusing after a while because you're going to have various different graphs on your paper. You can do this kind of 2 different ways. Since this is the last one, I want you to label it T for translation, and then I want you to circle it so I know that's your final one. Okay? If you're the type of person that needs to see all the previous graphs, you can leave them on your page. Okay? If you're not the type of person that wants all of that stuff cluttered on your paper, you can go ahead and erase the previous 3 graphs. So you can erase the P graph, the R graph, and the S graph because your T1 is your final. So if you need to see all of them, that's okay. Just make sure you circle your final one. But if you don't want it cluttered, you can erase all the previous ones. All right, so there we did. We graphed it by hand using the transformations. Let's go ahead and check and see how we did on here. All right, so y equals, we'll clear anything out and we'll type in the equation at the top. Now remember, to get out from underneath the square root symbol, you're going to have to use the arrow button so the square root stops, and then you can type in -3 on the end. I say that's pretty good. That looks like the green graph, right? That we said was the final one. I'd say that's pretty good. If you wanted to double check your points, you could hit trace. If you plug in 1, we should get -3, and that's where our beginning point was. Plug in 0, you get -1. That's where our next point was. So I'd say we did this pretty well. All right, let's go ahead and try another one. Can we identify any transformations? We're going to list them first. Yeah.
Reflector of the x-axis.
There we go. We have the negative on the outside. Okay, so x-axis flip. Any other movements, changes? Go ahead, Sebastian. There we go. Right 1, and then up 3. All right, so our order. We're going to start with the parent. Okay, that's the basic square root graph. And then we're going to go through the RST order to graph our transformations, okay, our changes. Now we did label a reflection. We got to flip all of those beginning points over the x-axis, meaning upside down. All right, so we'll get that blue graph and we'll label that R for reflection. It looks like we didn't label any stretches, right? No vertical stretch. So that's nice. That's one less thing we have to do. Last but not least, we have translations. So that blue graph, we're going to have to shift right 1 unit and then up 3 units. So take all the blue points and shift them right 1, up 3. All right, so we went through the RST order. Since the T graph is our final one, we'll circle it. Or if you want to erase the previous two, that's okay as well. All right, and then we'll double check it. We'll see how we did. We'll type in negative square root x minus 1, and then plus 3 on the end. I'd say that's pretty good. Looks like our T-graph, you can double check some points, hit the trace button. If you plug in 1, you get out 3, and that's our beginning point. Plug in 5, get out 1. Okay, that's another point that we had, so I'd say we did that pretty well. Okay. How are we doing with these transformations? Pretty good? All right, we'll stop there for today. We'll do a little bit more tomorrow. Okay, but we're going to actually get into like how these changes affect coordinates a little bit more, but at least for now we can recognize what values are doing. Are they shifting it up, down, left, right, flipping it, stretching it? Okay, we'll do more of that tomorrow.